Right, so in this first clip, we're going to look at the fundamental basics of NMR. We're going to look at a very simple molecule. That's the molecule of methane. We're going to take a CH4 molecule, and methane is a good molecule to use because it's purely symmetrical. 109 degrees tetrahedral molecule. All of the hydrogens are identical. Okay. So all of these protons around the central carbon are essentially the same. They're all identical. There's no chemical difference between them at all. Each hydrogen is a proton. Each proton has a positive charge. Each of these protons are rotating around their center of symmetry. Now, physics will tell us that a rotating charge will generate a magnetic field. That magnetic field, for argument's sake, can be going that way. Okay, much in the same way as we know spin does for an electron. It can have up or down spin. These are going to generate a magnetic field much in the same way. The protons have spin. In this example, for example, we're going to say they have got spin up. Okay, now that magnetic field is going to be small. It's going to be a tiny magnetic field by each of the small protons, each generating their own magnetic field. However, if we were to put that molecule into a machine which also has a magnetic field, okay, we'll call that B, the magnetic field. But if we put the compound that we're looking at into a magnetic field, and each of these protons are all generating their own magnetic field, their own tiny little magnetic field, and for argument's sake, they're all in alignment with the external magnetic field. If we were to then try to record or measure via a detector the magnetic field present around that compound, the machine would measure the magnetic field of its own magnetic field plus the slight increase due to X. Okay. Now, if the machine knew what its own magnetic field was, it could therefore, by measurement, calculate what X was. Okay. Which means that if we then had some sort of spectrum, so we measured from a point magnetic field and we scanned the magnetic field, all of a sudden we would get a peak. Similar to infrared, we would get a peak due to the magnetic field of the compound that we're looking at, or specifically of the protons within the compound we're looking at. That would correspond to magnetic field X. Okay, it's a very simple molecule. The molecules have one type of proton. The magnetic field is applied and the protons align themselves like little bar magnets with the magnetic field of the machine. We then scan externally the observed magnetic field and the machine calculates what X was. Now, because it's a very simple molecule, we just get one peak. Okay, and we can calculate or read off from the machine what X was. Okay, so think about that and look on to the next one. We'll build this molecule up slowly and try to get more and more detail.